take a look here. I got this here, 1140.4 basically x plus 17,600.5. And most of the people I looked at, you got those numbers, and a few of you guys that try to help you figure out. Because all it takes, it's the worst thing about data entry, is all it takes is you left off a 0, or you put a 2 instead of a 5, and the whole thing goes to shit. So that's the nice thing about it, me making you come up and show me your line of best fit scatter plot, is I can find a mistake and kind of help you real quick find it. So then, even if I didn't, I still grade partial credit. So as long as you show me you understand what you're doing, and it's just a stupid little data entry mistake, I'm not going to take a ton of points off for that. And then what'd you get for your R value? Yeah, 0.81, right? 8075, blah, blah, blah. And that by itself feels like it's pretty good. The sample size is actually a decent size. It's not a huge sample. It's a decent size sample. So, I mean, I feel pretty good about that R value because it's close to 1, further away from 0. So now in part B, I tell you exactly the divider line between enough evidence and not enough evidence. It feels a lot like the z-score comparison we did in the hypothesis tests. So I'm just going to tell you this number. R's got to be bigger than 0.482. So that is evidence of correlation. And since it's so much bigger, I would say that R means that it's decently strong positive correlation. So if R was negative, I'd need to see the word negative in there somewhere. Don't just say, it means there's some correlation. No, I mean, be a little more specific. Now, what I try to do with problems on the test is I try to find data that's really well correlated. Because, I mean, if you get down to like 0.6, it's almost like trying to describe wine or something. Yeah, it's got some correlation, moderate. I don't want to think about levels of adjectives to use with this. You understand? So it's either like weak or strong. Just to make it, so you're not worried about what kind of words you use to describe it. Are you guys with me? So that's what interpret R means. What does this R mean? It's positive and it's decently strong because it's pretty far above this and it's closer to 1. If it was 0.95, I'd say it's strong, right? 0.81, that's decently strong. So it's positive correlation, decently strong correlation. Now this is a separate question. What does this line? What does R tell us about the line of best fit? There's a couple different ways you can answer that. When R gets closer and closer to 0, what does that mean about my data points? They're getting further away from the line, right? So the fact that this is not close to 0 means my data points must be decently close to the line. And to go one step further, if I get anything more than that, that's evidence of correlation, I'm going to use the line of best fit to make predictions. But the more over this I get, the more I trust the line. So this R value tells me I trust this line pretty well to make predictions. All right, so two things you could say here. The data points close to the line. I trust the line to make predictions. So one thing I really want to make clear, obviously it's not my writing, but one thing I want to make clear is before we talk about line of best fit, our best guess is always the mean. So if the line of best fit, if the R value was below the requirement for evidence, I would just give the mean as my best guess for anything. That's always my best guess. But if R is bigger than 0.482, that means the line of best fit can refine that guess. I can use it to get a better guess. So if R is less than 0.482 in this problem, what would I predict for a state with 34.6? The average income. That's my best guess for anybody. But since the R is bigger than 0.482, I'm going to use the line of best fit to give me a better guess. Okay, I like it, because that line follows the data close enough that I'm going to trust it to make predictions. So hopefully you guys, this makes sense. These are my X's, these are my Y's. Nice XY table. So what does X mean? It means the percentage with at least the bachelor. So what am I going to put in place of X for part C? Yeah. And then when you do that, what do you get?
57,000.
Who is it?
57,057.3.
Something like that? Is that what you guys got?
Yeah.
Okay. And what's the actual income? That's the predicted income. And what's the actual? 55,368. So it's less than predicted, which on its own could be something to go analyze. Why was it less? What other factors are bringing that down below what I thought would happen? Especially if our R was even closer to 1, I'd go, why is that state so off? What is it about that state that might be affecting it? I mean, this is all, again, a lot of what we do in this is exploratory statistics. And then stats 2 would be, well, what do you do when you go in, when you're done exploring, you want to go in and freaking, why the shit is this happening? You know, that would be stats 2. That's further analysis. So this is a decent prediction. It's off by a couple thousand, but that's not too bad. Now, obviously, you know how to answer this question, but it's the details in the answer that matters. Do your results mean that if you get more people in a state to get a bachelor's degree, then the median income will increase? Is that necessarily true? Is that what the results mean? No, it's not. It doesn't mean that won't happen. I have no idea what would happen, right? And nowadays, the movement seems to be just get people degrees. I don't care what they do, just give them a degree, because that'll make everything better. Well, that's bullshit, right? So maybe it would, maybe it wouldn't. Maybe it's the money that they make that lets them go to college to get a degree. Maybe it's the money affecting degree, not degree affecting money. And I'm sure that's a part of it, you know? So there's a lot of factors here. Maybe there's a third thing affecting both. So, does it mean this? No. This is a correlation, not causation. So all I know is as one changes, so does the other. I don't know if one affects the other one. I don't know if the rise in bachelor's degrees would make the income go up. It just, all I know is when I see a state with more bachelor's degrees, I expect its income to be higher. I have no idea if that affected that or the other way around or whatever. You guys understand? It's just like the whole, if you play basketball, you get taller thing, but taken to a less obvious degree. So on one level, of course, this makes sense. If you have more people with bachelor's degrees, you should probably have a higher median income in that state. But on a smaller level, you know, the differences between states and all this kind of different stuff and the choices people make for jobs, you don't necessarily choose a higher paying job just because you have a higher degree. All this stuff is kind of what makes it wiggle a bit. The dots don't all line up. Okay. How do you guys feel about that? Were you guys able to get here's what it looks like. So we hit Zoom 9. Oh, poor little thing. Shoot bright. Bright light. There we go. You guys see that? Is that cool? Is that what you guys got, roughly? Something sort of like that? So to be honest, I kind of cheated a little bit. Let me show you. If you have one of the newer calculators, I don't know if you guys realize this, when you do the calculation, you can actually tell it to store the regression equation. You have to tell it. See this little button here, vars? It's not vars revenge, but you hit vars. You go to y variables, function, y1. So it's going to store it in Y1. That's exactly what I did, and that's why all those freaking decimals are in my Y1. If you don't have one of the new ones, you just write it down and then enter it manually. Right. Smack. If you get a dim mismatch error, right? The calculator's not trying to insult you. It just means that the dimensions of the lists don't match, which makes it freak out. It's got to be this goes with this goes with this goes with what the shit, and it's going to freak out. And that, of course, sometimes it's the worst thing because you're like, oh crap, what did I forget? Oh crap, you got to go through each one. Oh well, that's part of the beauty of data entry.
Beauty. Like 2,000 data.
Good Lord. Yeah, it's not gonna happen in here. That would suck. Okay. Anything about? So this is what I want you to show me. You come up to my desk and you show this to me. Show this to me on the day of the test. If you don't, you just lose points for that part. Yeah.
Can you go through the calculator steps one more time?
So put the data in.
Yeah.
So let's do. Then go to Stat, Calc. It kind of gives itself away. Number 4. Now, if you have the older calculator, it'll just say linreg, and it defaults to list 1, list 2. So you just hit enter. Me, I gotta kind of go through this crap, and then there you go. Now, on the day of the test, if you have a calculator that's not showing you R, please, dear God, just come up to me. It's just a little thing I gotta do real quick, and R will show up. Don't write a little note. I hate that. My calculator didn't show me. Well, then come up and tell me that, right? So don't write me notes. Just come up and say, hey, my calculator's doing something weird. Okay, and I'll help you figure it out. And then, write this stuff down and put it into Y equals. And then whenever you put new data in, you've got to hit zoom 9. Otherwise, you end up with something like, you get something like this when you hit graph, and you're like, yeah, cow eating grass, right? No good. So zoom 9, it finds the data for you. Schnosh. Any other questions about any part of that? All right. Take that as a no because there's several people falling asleep because the lights are out. Yes? Oh, we didn't have... Oh, I see. It was stuck trying to do something. So you got to turn this like plot. Turn on. Okay. Okay. I'm going to turn the lights back up. Wake some people up. Just to say a few words about what we're about to get into. Now, I wanted you to realize this. We have 1 day left. Is that true for new stuff? If I'm thinking correctly, is that true? Yes, because next week will be Monday, and then this review for the final. Holy shit!
So it's on Monday.
Yes. Well, all right. I'm not going to do a quiz on Monday because we haven't really played with this long enough for me to do that, and I want Monday to go over what I can in chapter 12, I think it is, or 11. I can't remember. So the one about the chi-square. I love you guys. He doesn't have the book memorized. What a jackass. No. So the one about the chi-square distribution. And chi-square, just to say a few words, and then we're going to leave like really early. And if you don't like that, it's too bad.
No.
I think most of you guys probably know. Chi-square.
So fancy X squared.
I don't know. Are there any Greeks in the audience? They won't like that. That's...
So if I draw chi on my test, you get extra credit.
That's the Greek letter chi.
That's the tattoo.
The square.
No,
So guys,
Square, yes.
this, what does that mean?
Baby sigma.
A variance.
Variance. And the square is there to remind you that you haven't taken square root yet. This is a part of the symbol. This is not, there's not a chi that you square root to get. That doesn't make any sense. If you say that, a stats person would be like, what? And it's got a really interesting backstory to it. It's basically, it's if you take the z distribution and you fold it on itself. So what you end up with, and maybe some of you guys will realize what's going to happen here. We're going to have another chart because we have a different distribution. And if you did take more stats, there would be even more charts because there's even more distributions. So because we have a lot of different situations, and different situations sometimes need different distributions. I love you guys. So on Monday, I'll have the chart that we're going to look at. I think I'm only going to end up doing a couple sections out of whatever that chapter is. We're not going to do all 4 sections that's listed on the homework sheet. But this is not going to be normally distributed. It's going to look like this. And what is? How would you describe that? Let me see if anybody's.
Translated normal distribution.
I like translated. It's interesting, but it's not quite translated. It's actually just pulled. So that is skewed to the right. I like it. I also call it Jabba the Hutt, but yeah. So we'll talk a little bit about this on Monday about why it's shaped like this. Now, the unfortunate thing about the chi-square, you might realize that does mean something still. It means that the lowest it could be is 0. So it is not symmetric anymore. You know, z-score stuff is nice because it's symmetric around 0. So if I want to get the 95% confidence interval, it's going to be negative 1.96 to 1.96. Yay! Here, if I want a 95% confidence interval, it's going to be something to something completely unrelated. Right? It could be 3 to 87. So it's going to have to come off that chart. Oh, I love you guys. The other thing with this is it's related to the t distribution in the fact that it looks a little different based on how big your n is. So the chart's going to be based on degrees of freedom and how confident, like the alpha, the amount in the tails. So you could do a lot with this. You could do hypothesis tests. You could do, what we're going to focus on, I think, is called goodness of fit. Goodness of fit. My goodness. You can tell, like, the problem on the back talks about M&Ms and how are the M&M colors uniformly distributed. How closely does an observed distribution of M&M colors, how closely does it follow a uniform distribution? So that's one thing this is good for is seeing how closely something like grades. I could say, your grades, how closely do they follow a normal distribution? I can actually use this test to see if they follow it or not. Okay, I like it, sort of. And something interesting about this is, whenever I discuss this, I like to say, if I wanted to do a hypothesis test about sigma, why could I not use the normal distribution? Well, what determines the shape of the normal? If it's skinny or fat, what determines the shape? It's frickin' sigma. And if it's sigma you're testing, you want to know how sigma is distributed itself. Not, this is sigma just tells you how fat or skinny it is. I want to know how do the sigmas distribute. That's this. This is what they look like when you do the sigmas. So that's why this would be used for hypothesis tests, for variance or standard deviation, for confidence intervals, for standard deviation. You would have to use the chi-square distribution. So hopefully on one level that makes sense. Like, this can't represent sigma because freaking sigma helps you figure out what this thing looks like. Sigma is a parameter of this. It's not how the sigmas themselves would be distributed. Okay. So we're only going to do a couple things out of that section. Goodness of fit is a relatively simple problem. Most of Monday, I think, is going to be based on figuring out how to read the chart and then what to do when I find the values from the chart. All right. And I'll have the practice final on Monday. Yeah. Practice final time already. So if you didn't realize that, yeah, practice final answer key. Yeah.
Again, remind me again when the final is?
It's on the homework sheet. That's why I do that, because so it looks like past me thought it was going to be Monday, December 11th at 11:35. So please note, all your final exams could be earlier or later than the normal time because they have to be able to fit all the classes in. And I teach a 50-minute class. That means 4 days a week, and it gets 2 hours for its final. So that means everything's got to kind of move around that. So we start 11:35. If you come late to it, I'm going to decide you chose to just give an hour away. I'm not going to give you extra time.
Wait,
So
the test starts at 11.
the final starts at 11:35.
I have a class that goes until 12.
No, you don't.
No.
No, you don't. When the finals start, classes are done. It's only finals. That's not me saying I want this to start at 11:35. That is the school schedule for the finals. I love it. So make sure you really know what time your finals are for your other classes, because the time's probably changed a little bit. All right, I think that's enough for today. We're going to leave really early. Yeah, please come up and get your IDs back. Thank you. Oh, is this yours? Yeah. I've still got to try to make a makeup test for test number. Huh?
Number 2?
Yeah.
Okay, when could I take it?
Well, as soon as I get a makeup test made, I'll let you know. And if it turns out that I run out of time, I'm going to have to count the final for more to cover for that. So we'll see.
Oh, I know why though.
Okay.
Yeah, why? Because of that what?
Oh, you can have this.
Really?
Yeah, sure.
Thanks.
It's about that.
It's on the website, guys. All right. What's happening, sir?
I went through all the
Did you get the? So you already got this here, right?
Yeah.
So go to y equals. See y equals. Y equals. Yeah, you got that in there. Okay, but you just left the x off. Oh, you got a theta because it's all freaky, I think. Okay.
Oh, okay. See, when you said instruction, I wasn't sure.
There we go. There it is. Okay. So now if you hit zoom 9, and see 9 is the zoom stat. See it? Zoom stat. Right, now the other thing you need is you need the stat plot turned on. See stat plot? Yeah. So all you have to do is on the day of the test. If you're having trouble, just come up and see me. Okay. I hit zoom 9. 9. Yeah. There you go. Okay. Oh, how did you find this out? Oh, you just copied it from me?
Yeah.
Hit stat. Stat. Calc. Number 4. See, there's a line. Go down and calculate. Enter. Yeah. Oh, okay. Yeah. So again, on the day of the test, don't worry about this. Now it'll show up. So if it's not showing up on the day of the test, just come up and see me. I can do the little thing and make the R show up. Okay. Sure.
Just to double check, we're skipping a chapter or a section from chapter 11, right? A section from chapter 11. We're going to be skipping one?
A
Isn't that
couple,
what you
but I haven't
oh,
said
couple?
yet which one.
Okay,
Yeah.
never mind.